Hi team, I believe we are doing well. Welcome to our today's session. I can see we are few. I don't know where are the rest. I've even extended some time so that we can allow everyone to join so that we can start together. We are covering our last module, that's on digression. But before we start, allow me to welcome Nicole. I believe we can have opening remarks, and then from there we can start. We can have just a recap for 1 or 2 minutes. From then we can start our new module that's on digression. So Nicole, if you can hear my voice, I would like to hand over the mic to you so that you can do an opening remarks, and also you can select one or appoint one of you to pray for us as we start our today's session.
Good evening, everyone. I hope we are all well. Thank you. I would like to welcome us all to today's session. I hope that we are ready to learn and that what we will be taught, we will be able to understand, and we'll be able to use it in our careers. With that, I would like to welcome Zadok. If you're able to, in a position to speak, could you please start us off with a prayer?
Okay, we are praying. Father Lord, we thank you for again bringing us together via this call. May you walk with us, may you guide us, forgive us our sins, anything that we may have committed knowingly or unknowingly, Lord. Father Lord, may you forgive us, and Father Lord, may you walk with us, may you guide us throughout this session. May you be with our teacher, our guider. May you walk with him. May you also grant him your knowledge, Lord, so that, Lord, he may also deliver all that you have planned as a human being uh, in the correct way, Lord. Continue guiding us, continue working with us. I pray that short prayer, trusting and believing in your holy name, Jesus Christ. Amen.
Amen. Thank you for that, Zadok. Again, welcome all. Back over to you, Zablam.
All right. Thank you, Nicole, and Zadok for a wonderful prayer. So, welcome again to today's session. So, we are going to start with just a recap on what we covered during our last session, and then from there now we can proceed with our today session. So without changing our screen, allow me just to highlight. During our last module, we were looking at various statistical tests that you can use to test hypothesis. And during our last discussion, we looked at ANOVA. And then from there now we looked at regression analysis and the Pearson correlation, where we sent all these, you remember the decision on where we saying that if the p-value is less than the alpha value, that means there is a significance, either difference, might be a significant effect, depending on the hypothesis that you have formulated. And then from there we say in that direction, if that's the p-value is less than the alpha value, there is a significance, there is a statistical significance, and from there what you need to do is to reject the null hypothesis. Always remember the type 1 error where we saying that reject the null hypothesis when it is true. So our truth is that there is a significance and we need to reject the null hypothesis, and in that direction we favor the alternative hypothesis. So again, we went and looked at regression, where we did a regression analysis, and we looked at the significance values depending on the number of variables that you have used in your model. So we looked at the significance levels as well. And the same applies, as we have seen. If the p-value is less than the alpha value, then there is a significance, either difference, either relationship, either a significant degree of relationship. And from there, you reject the null hypothesis as you favor the alternative. So from there, we looked at the Pearson correlation, where we said for the Pearson correlation, you check on the degree of a relationship, where we said we have the relationship can be either a strong negative, weak negative, a weak positive, or strong positive correlation. So that one now helps us to again understand or know the direction. If it is a positive, strong positive, of course, the sign positive shows that there's a positive projection. If it is a negative, then it shows again there is a negative projection. So that gives you a direction. Same case with the regression. It can give you the direction as well. And also it can give you the degree of influence, where we said if one unit is added to the independent variable, what will be the impact on the dependent variable. So that is known as the degree of influence. So I think that's what we are able to cover, but I know we will be able to do some analysis as we proceed, or as we maybe venture in the practical part. We will be able to look at the practical part of it and be able to do 1, 2, because ANOVA will also be, there won't be a table on ANOVA as well, and we will be able to understand why ANOVA is important as we look at some other key features under these ANOVA analysis. So for today, we are starting a new module. That's on regression module. And I will say that all these modules are very important. All these modules you can see here are very important. The beast of biasness, I said we are going to cover some of the assumptions when we'll be looking at the regression, and I'm sure we are going to cover some. So again, on some other assumptions, we won't be able to cover when we'll be handling this module specifically. And some other tests, as I said, for hypothesis testing, among others, will be covered in some other sections like non-parametric test, statistical test, maybe in advanced data management, and some others in time series. Even as we cover the regression model, there is some of the assumptions that will be covered in time series, like autocorrelation. You can be able to cover these at these when we'll be addressing this module. So these modules are very important so that you can be able to expound more knowledge in this area of data analysis using SPSS. So these are the course objectives for this module. One of the objectives is to be able, at the end, I hope that every one of us will be able to test and explain the assumptions of linear regression, analyze and be able to tell whether there is normal distribution, whether there is a linear relationship, whether there is autocorrelation, whether there is almost stochasticity, and so many other assumptions that you'll be able to confirm. Now, the second objective is that I believe that all of us will be able to conduct multiple regression analysis, where now you have more independent variables against the dependent variable, or more independent variable influencing the dependent variable, and you will be able to know which variable is influencing the other when we'll be analyzing, or when we'll be generating regression model. Then another objective is to access the model fitness. Remember, you need to confirm, is the model fitness, is it varied, is it reliable, so that you can be able to confirm again. I can proceed analyzing, I can further this data in terms of analysis. I can do some other analysis like time series. If the data is big data, or you have more variables, you can proceed with other advanced analysis. So that's the reason why initially when we were starting this session, we looked at descriptive statistics as well as the exploratory data analysis. Remember, we said that we want to derive a pattern. We want to understand this data before we dive deep into these analyses like inferential and some other kind of analysis like regression and others. So it is very important to understand that exploratory data analysis is very important. And even when we will be looking at some of these assumptions, we won't be referring to exploratory data analysis, because I remember there was a question by Samuel who was asking, now, if I want to confirm these assumptions before I proceed with the analysis, where do I start, or do I have to go to regression analysis so that I can be able to confirm the assumption? I say no, you need to do, or you need to use the knowledge that we gain through the exploratory and data analysis, because I know we did so many analyses there when we were doing the descriptive and exploratory analysis. And I'm going to repeat some of them so that you can be able to understand well. You don't need to go for regression so that you can confirm if the data is normal distributed for you to proceed with parametric tests. No, you can do it when you will be doing the exploratory, confirm whether there is a normal distribution, whether there is multicollinearity between the independent variables. And from there, you can be able, even when you have confidence already, you know, if I go ahead and do the inferential statistics like regression, Pearson correlation, ANOVA, already I know I will get a positive result. There won't be a significant values when I will be generating these kind of models. Now, from there is an interpretation of regression coefficient. It's very important again to understand, to know in how one independent variable influences the dependent variable. It is important to understand those the coefficient values under the regression model. We are going to again to look at that, and even we are going to look at the variances, the variation in terms of independent to the dependent variable. We are going to see how does independent variable or the limit in which the independent variables influences the dependent variable. But this one we can create in terms of a percentage. So we are going to, through the model summary, we will be able to know at what level does the independent variables influence the dependent variable, so that again we can be able to know if the variable that we have picked or we have selected, are they enough to explain the dependent variable. Like for instance, if maybe we have selected dosage, assume we have dose 1, dose A, dose B, and dose on drug type A, drug type B, drug type C. And then again, we look at the age in terms of the BP reduction. So remember now the BP reduction is the dependence, is the depending on the age and also depending on the drug type. So if we analyze the two, then we will be able to know at what level both combine, that's the age and the drug type combine contribute to the performance, to the to the BP reduction, reduction. So we will be able to do some of the analysis, and you will be able to know how again I can predict, because regression analysis is to predict the outcome, and you can even be able to derive the pattern as well, even from the initial exploratory. It's like furthering the pattern as well, diving deep to understand or to get more insight from the data. Now, from there, we look at the regression. This is our main discussion, the regression. We won't be able to go again to know there is a different types of regression at different levels. For now, we will look at the simple linear regression and the multilinear regression. From there, when we will be able to advance, we will be able to look at some other advanced levels of multilinear, the regression analysis, which will need more data, or which will need more understanding on data, and so many other things. Now, regression is a powerful statistical technique. As I said, it helps to determine or to examine the degree of influence between one dependent variable or more, between one dependent variable and one or more independent variable. So those are the variables we call predictor. So anytime you see the word predictor anywhere, just understand those are the independent variable. And actually, as the word stipulate, the independent means something that does not depend on anything. It is not influenced by anything. Although we have some moderating variables, control variables that might influence both hands, that's the independent and dependent. But in layman language, independent means does not depend on anything. But independent means for it to maybe to have some impact or effect, it shouldn't be triggered by something else. That's the reason why we have the one dependent variable. Now, this allows researchers to generate model, analyze, predict outcome, and quantify the strength and the nature of the relationship between these variables. In our area of speciality, the regression analysis will be widely used to explore. So we won't be able to use this regression analysis to explore how variables such as age, weight, dosage, or drugs, lifestyle factors influencing clinical outcome, like blood pressure, cholesterol levels, recovery time, treatment effectiveness. So I know those are the kind of data that you might access or maybe come across with. Even you can go ahead and collect those kind of data, and it is important again to know how to analyze or which models you can maybe further continue with to do the analysis. For example, if you're looking to predict a patient's blood pressure after treatment, you can check on the age, initial blood pressure first, and then you can also check on the cholesterol levels. I know those are factors are very important in or they contribute much on blood pressure. The cholesterol, you need also to check on the initial blood pressure because we are looking at how these variables influence the dependent variable. Now, from there we have core assumptions of regression. I'm doing this because I know we are not able to cover the module that I said on the biasness, but I know there are more. When you'll be looking at that module maybe one time, we'll be able to expound more to understand more assumptions and how to test both statistically and also how you can use some diagrams to interpret as well, like chart, histogram, and so on, so that you can understand both the hand. But for now, you're going to look at some of them, the assumptions, especially that affects or that influences regression. So these assumptions are fundamental conditions that must met. If not, then we'll be unable to verify or to validate results. Will not be able to generate a model that will be reliable. Remember that I think there is something first we need to do, like a reliability, and reliability is very important. We check on the we check on the instrument that was used to collect data, but in real sense, we are analyzing the data. Of course, for we to be able to know whether the instrument is reliable, we need to analyze the data that we have, so that we can know whether in terms of we met or the data meet the threshold that is needed. Some of the researchers will recommend for data to be reliable, you need to get maybe a Cronbach alpha of 0.5 and above. Some others like Mogenda and Mogenda recommend Cronbach alpha of 0.7 and above. But all these, I know, won't be able to cover when you'll be looking at some other levels, as I have said, because for now, we are looking at one step at a time and one module at a time. I know we'll be able to look at that and even more how to do variable computation, but I'm going to show you maybe before we complete this cohort, so that in case maybe you find a data that maybe as use a Likert scale, you don't get lost, but I will be able to explain to you on how to proceed from there in case you have a data which you have maybe collected, or maybe someone has shared a data that has been that have used a Likert scale. So I'm going to show you how you can compute a variable, and even when you proceed with the regression analysis, I'm going to explain some of the concepts that's really important for you to be able to interact, or for you to be able to analyze all kind of data that maybe you can come across with. Now, we have seen that the assumptions ensures that the relationship modeled between the independent and dependent accurately reflects reality, and the statistical tests are appropriate. So that's the reason why we are saying before you proceed with the inferential analysis, that's the regression, Pearson correlation, among others, before you proceed from there, we need to confirm to know whether first the data is normally distributed, whether there is a multicollinearity or a strong relationship between the independent or the predictor variables. So we need to check all that so that we are sure even when you proceed the regression analysis, the data or the output will be significant. Now, why the assumption matters? Because violating these assumptions, if we assume, it's like we assume now we have tested the assumptions and we are okay, we can proceed. If we do that, if we fail to observe those assumptions, then we will have biased and inconsistent coefficient estimates. Those are some of the constant terms, or maybe The gradient that I talked about when I mentioned linear regression, y is equals to mx plus c. Remember, it's saying m is the gradient. So those are the coefficients we are talking about. So we will have inconsistent coefficient, and also we'll have some biasness in this on the same as well. Then we will have invariant significant test. The p-values will be insignificant, and you will not be able to see or maybe to stipulate the relationship or between the independent and dependent. We will not be able to show that. We will not be able to confirm. We will not be able to verify some of the arguments because of the biasness. Misleading interpretations or prediction. Yes, we can also get some misleading interpretation because, for instance, we know that, brand pressure, we can say that age contributes much on brand pressure. And then you get your result that, when you want, maybe when you get a year holder, then it shows that your brand pressure might be going high. So that means increase in age, there is an increase in brand pressure. But now your analysis shows opposite, that when you get older, then the BP goes down. That one you will not be able to confirm or to verify or even to align with other researchers. So those are the finding that we are saying now. They will be misleading, and we can't even predict. We can't even predict maybe the outcome in terms of the variables that we have selected. So it's always important to ensure that first you confirm those assumptions before you proceed. Now, some of the key assumptions that we will be looking at under this module. One is linearity, which says that the relationship between the independent and dependent must be linear. So we won't be able to know how we can test that, both statistically and also through diagrams. Some of those diagrams we did during the exploratory of data analysis, but it's good again to get more insight about it, so that we can, when you'll be doing the exploratory, we can only just proceed the regression analysis. We have confirmed that the data is normally distributed, there is a linear relationship, there is no multicollinearity. We can just proceed the linear regression, or we can just proceed the multi-regression, and that's all. Now, the second assumption is normality. This one I think I've mentioned severally. We say that the data must be normally distributed. And mostly on the normality, there is a two-way on normality. You can either use one, we use the QQ curve. There is a curve, we call it QQ. And this QQ, you use the quantile. We use the quantile to determine the normal distribution. We just generate a diagram of which we are going to see how the diagram looks like. And also you can have the PP curve as well. This now uses the probability. The 1dp stands for probability, and the 1dq stands for quartiles. So we won't be able to understand more about that when we will be performing, or when we will be testing the normality of our data. Then we have homoscedasticity. This one says that the variance must be constant. It's opposite of heteroscedasticity, which says that there is unequal variance. So, but we are going to test homoscedasticity at this level for the regression purpose. But when we'll be looking at the biasness there, we will look at so many assumptions that you're going to maybe interact with in various sections or in various models. So we are going to mention all those. We are going to discuss them in details, because some we can discuss them in this level. Same case when you are doing the hypothesis testing. We are not able to do all the statistical tests for hypothesis because some are covered in other modules, but you are able to mention, at least you understand there are some other options on hypothesis testing. Now from there we have multicollinearity. Multicollinearity in layman language, this one means that there is no strong correlation between independent variable. So for this one, we are looking at the relationship between the independent. Among the independent, if there is a high correlationship, if there is a high correlation between the independent variables, then that means again there will be a problem when we'll be conducting the regression analysis, or maybe the output of regression analysis might be biased. Then again, no autocorrelation, but this one we will look at it when we're looking at the time series data. So for now, we will not be able to cover the autocorrelation because that one will be covered in another advanced module. But the rest we will be able to look at one by one as we proceed. Now we start with the linearity. By the way, before I proceed, anyone with the question? Anyone with the question before I proceed from there? Let me know if there is anyone with the question. Yes, if you have a question so far, you can drop your comment on the chat. If there is any question, you can drop your comment over the chat. I'll be able to address as we proceed. Maybe there is something, there is some of the concept you didn't get well. Make sure you drop your comment on over the chat. I will be able to I will be able to address as we proceed. It's very important. It is very important. Now we start with the linearity. So for this one, I've already seen that the relationship between independent and the dependent variable should be linear. It means that they should be straight. Linear should be straight, not a curve. It should be straight. Why is it important? Linear regression model models the means of dependent variable as a linear, a function of the predictor. So when we just key in or we select the variables, then from there the system or the software be able to do all that, calculate the means and all that, and then what you'll be able to see is the output. But if you are doing it manually, then you will be able to use a formula, and you'll be able to do maybe to show the work plan, what you have done, you are working, I mean, you'll be able to show your working from the formula, how you're going to substitute and all that. But using the system or using the software, it makes your work easier because you just give a command, select the variables, and then from there you get the output. Now, if this relationship is not linear, prediction and coefficient may be accurate, definitely. So it's good, again, to understand or to confirm the linearity before you proceed. Now, how to confirm the linearity? Remember, we looked at the scatter plot. I believe you can remember that. We did a scatter plot diagram, if you remember. So that's one that you can use to determine the linearity. And we are going to repeat that. Remember the scatter plot, we looked at it during the exploratory data analysis. I hope Samuel is on the call so that he can be able to confirm, because I'm going to, again, to explain or maybe show you how scatter plots are generated and how you can interpret as well. Option number 2, you can proceed the residual plots. This is where now you can just incorporate regression and you'll be able to get some outcome there, which you'll be able to interpret later when we'll be doing now the actual regression analysis. Now, an example is to predict as the boring blood pressure, that's SBT, using Eng, assumes that SBT increases or decreases in a linear pattern with Eng. That means that if Eng increases, then we assume that the blood pressure increases. I'm not sure, but it's going to do the analysis so that we can verify or confirm the claim. That's the reason why we have to do a data analysis to confirm or to verify the claim or maybe the argument or so. Now, in linear, you'll be able, these are kind of a scatter plot diagram. Those are kind of a scatter plot diagram. We have said you need to know how linear looks like and how non-linear looks like. That's the scatter plot. We are talking about the scatter plot. These are the scatter plot diagram. But you can see here we have a positive linear association. What does that mean? When one variable increases, the independent increases, the dependent increases as well. That's the reason why we give an example like Eng and brand pressure, where now if Ng increases, I mean, if the older you get, the higher the brand pressure increases. I'm not sure, but I know those are some of the facts. So that one gives you a positive linear association. And you can see the arrangement of the data distribution. You can see they are in a linear. Now, on this other end, you can see we have negative linear association. This means now when one variable increases, the other decreases. When one variable increases, the other increases. It might be the opposite. It might be, of course, it should be that's the independent decreases, because as you can see here, when the independent, when independent increases, then the dependent decreases. When this one increases, this one decreases. So that's the reason why we have a negative linear association. Now I want you to look at these two. You can see the data here is distributed, but as you can see here, there is no linear. Can you identify any linear on this one? There is no association there. You can't even tell whether the data is positive or negative. You can tell. Same case on this one curve here. This shape here, you can't again tell whether this is a positive or negative linear association. Something else that you can also be able to identify through this scatter plot, you remember the outliers we are talking about? The outliers, but in this case, for these diagrams, you can see no outlier. An outlier we say is a data that is, it's a data that's actually far away from the rest. So maybe we can have a data point at this point here. In case we have a data point at this point, that means this is an outlier. It's not within this other data range. It's outside the data range, so data set range, and that means this data is an outlier. Remember, we talked about the outlier. We said we have the two types, mild and the extreme outlier. So don't forget about that, because when you do analysis of the SPSS, you'll get those kind of output, and you need to explain. Now, I believe that one is okay, and as I have said, we are going to do the analysis on that, on the scatter plot, so that we can be able to understand again how we can conduct a scatter plot analysis without going through the regression analysis, because again, doing it when you are doing the regression analysis, it's like it might be a double work, because your analysis, you are not sure whether you will the assumptions will be violated or not. But it's good to just to understand from the exploratory data analysis part, as you maybe so that even when you proceed to the inferential analysis, you know already what kind of analysis are you going to conduct. Is it non-parametric? Is it parametric? Is it inferential? I mean, it's inferential, or what kind of analysis are you going to proceed with? Now, on the normality, the ratios or errors of the regression model should be approximately normally distributed. This one, you can say the data point must be normally distributed, And for it to be normally distributed, remember we are using, as you can see here, I've used two diagrams here how to access. You can use histogram, QQ plot, or PP plot. Sometimes when you use the regression, you get this PP plot, but even for both, you can generate on the data descriptive analysis stage. You can be able to access the QQ plot and the PP plot as well. You can be able to access that. Then on the statistical analysis, now you can use Shapiro-Wilk tests. You can be able to use that. If it is non-parametric, then we can use something we call Kolmogorov. There is something test called Kolmogorov. You can use it, but for now, we are going to focus on Shapiro-Wilk tests. That one, we are going to do that as we proceed in the practical part of it. But I want you to understand all these diagrams. You remember we did them during the exploratory. So you don't need to do the statistical analysis. Like you need to use the tests like Shapiro or some other for you to confirm there is a normal distribution. You can just get from the diagram. Like what I've shown here, you can just from just the diagram, you can tell there is a normal distribution, there is a linear relationship, and so on. Even you remember we talked about the cross tabulation. We did a cross tabulation when we were doing the exploratory as well. Cross tabulation, we saying it helps to understand the relationship between some two categorical variables, but which you can even use the continuous as well, if only you can be able to compute the variable, the main variable that can be able to accommodate some other variables. Because computing a variable is like a summary which summarizes maybe 2, 3, 4, 5 variables together. Then we can call it a computed variable. So if you know how to compute that variable, again, you can even do a cross tabulation, and the same can give you a picture, a pattern, whether there is a collinearity between the independent variable. So for this one, we are going to do as well. We're going to check on the normality. And as I have said, we are going to look at the histogram, the QQ plot, the PP plot again, and then from there we can proceed the Shapiro-Wilk test. Now, these are some of the diagrams that represent the outcome on the PP, and these are the histogram actually. These are the histogram. We will look at the QQ and the PP, how they look like, but these are the histogram. Now, if your data is normally distributed, this is the first diagram that should show you how the normal distribution of data looks like. A normal distribution of data should look like a bell shape. That's the reason why you can see this bell shape here. This shows there is a uniform distribution of this data. So we can confirm if this there is a bell shape, data distribution shape, then we can confirm the data is normally distributed. But I want you to have a look on this other. If you try to, for you to be able to draw these lines, I believe you can see how these lines are drawn. We just use the edges, for you to be able to draw that. If you look at this, one here, the 4 histograms of the same thing with the Kennel Destiny estimate, you can be able to see there is no shape. Even you can't explain what kind of a shape is that. Or can you be able to explain the 4 of them? Can you be able to explain? Can you be able to draw this bell shape? You can see we are trying to draw a bell shape, but the outcome is wanting. So there is no bell shape here. So in case you have a curve, like for instance this one, some of the data might be skewed on the right, some might be skewed on the left. So you will find so many kind of diagrams here on histogram. But what I want you to understand, because here you just need, you make judgment by using your eyes. You make judgment by use of your eyes. You'll be able to confirm whether this data is normally distributed or not. I believe we are together at that point. Now, from there we have, so these are the PP curve. I've just indicated is a histogram. Allow me to end this. These are a PP curve or QQ. Allow me to rename these QQ, stroke QQ stroke PP, PP curve. Both will look the same, or the two, that's the both QQ and PP curve will look similar. Now, I want you to look at this one for you to be able to understand by look of a curve or a PP or QQ curve, you'll be able to tell whether the data is normally distributed. Can you see the first diagram here? The normal distribution. You can see the data point are within this line of fitness or line of good fits, if you remember those high school mathematics. So you can see that the data points are distributed within the line of goodness fit. You can see all data points are within the line. This is a linear. We can call it a linear line, or yes, we can use that one. So you can see the data points are distributed within this line. But if you look at this data, we only have 1 point on the line. All others are outside the line. So this is skewing to the left, skewing to the left. Now from there you have skewing to the right, and you can see the data point now moves up, upward above the goodness line of fitness. You can see it. You can see the data point. Now these others, we have the big tail, we have the thin tail. So, but at the end is to understand if your diagram, if your QQ or PP curve doesn't show this kind of this is a kind of a diagram, then it means that your data is not normally distributed. So it's good to understand that as well. It's good to understand that as well. Now, I don't know whether we can, let's first do the two first that we have done for the normality. We have the three, linearity, and then from there now we look at normality, and then we proceed the histogram together with the QQ curve. So I want us to do that first, then from there we can proceed. Now we start with the linearity. We send for the linearity, we can use the scatter plot, and allow me to use one of the data that you have been using. Actually, we can use the previous data. We can use the previous data that we are using, or any other data, as long as you can be able to identify the dependent and the independent, then you are okay. You are free to go. So for now, allow me just to use one of the data that I have on my screen. I think this data, we have used it for long. We have used this data for long. We have used this data for long, but it's good. Let's use it again. Now, we are saying we want to analyze, or we want to confirm the linearity. And for the linearity, we are saying we can use a scatter plot to test the linearity. Now, in that case, there are options to test our linearity or to get the scatter plot. Remember, we said you can just go to graphs, and then from there you can use either chart builder or legacy. So allow me to use, let me just use the chart builder. Any can work, by the way. Any can work, either chart builder, or you can either use the chart builder or legacy as well. Now we select the scatter plot, and then from there now I use simple. Let me just use a simple, and then from there, remember here I'm using the two variables, so I need to use the independent and then the dependent variable, the dependent and the independent variable. So in this case here, allow me to use let me look at the variable that I have. We send inch is the variables I have is let me check here. I have the treatment type, I have the BP and all that. I have okay, I can look at the treatment type. I can look at the treatment type and then BP reduction. Allow me to use those two. The BP, the treatment type, and the BP reduction. I will use the BP reduction as my dependent variable because the BP reduction needs treatment. That's the reason why I've selected treatment type, drug A, drug B, drug C. Remember the column that we assigned them. So that's what I'm going to use. So now on the x-axis, I may use, the x-axis always represent the independent. I mean the dependent variable. So in this case, allow me to use on the y-axis, I use the BP reduction. And then on x-axis, I use the x-axis, you have seen treatment type. I use a treatment type. But as you can see there, we have only 3 data points. So we can't even tell with the 3 data points. Is it possible to confirm that there is a linear relationship? Is there a linear relationship between? With the 3 dots, we may not be able to confirm that. Unless we use maybe, but then for this one, scatter plot here, we may not be able to use more than one. We will not be able to use more than one independent variable. This one limits us, and we will not be able to use more than one independent variable. Dinette is saying, I'm requesting if you can please launch the poll. All right. So let me launch the poll and make sure you mark yourself present. Yes, this is very important. Oh, and I forgot to make some announcements. Assignment 4 is on the classroom, Go Classroom. So please make sure you attempt as well. And I'm so grateful that 20 of you have managed to submit the assignment 3. So I'm grateful for that. I'm yet to mark, but I'll mark over the weekend, even as we prepare to do the assignment 4. And even as we aim to complete module 5, I mean, these are the module on regression analysis. So please make sure you do as well, submit, so that by the end of next week, we are done with this course, we are done with the awarding marks, and also maybe the executive can be able to prepare for the next step for you guys. So this is how the scatter plots looks like, but this one we have only one. Let me just look at, let me just remove the BP reduction, and then, or maybe I can have BP reduction and some other, yes, I think it's this BP reduction. Allow me to have another variable or BP reduction on y-axis, and then on x-axis, I can have another variable, maybe age. Let me have age and see how it looks like. Now, can you tell now? I think this one makes more sense. Let me click OK, and so that I can be able to share the outputs. I believe you can be able to see there are so many analyses, by the way, and all that we have done. So let me share the output. Let me share the output so that you can be able to confirm. Now I'm going to start here. So you can see there is a graph. You can see there is a graph. So can you tell age and BP reduction? Can you tell the two whether there is linear relationship or not? By look, let me get your answers over the chat. You can just type, is there a linear relationship or not between age and BP reduction? By look. I think I have one from Sarah. You can drop a comment over the chat. Just confirm and tell me whether there is a real relationship or not by look. So I think somewhere you can now see what you are talking about, the exploratory. We send we are driving pattern so that we can proceed in the deep analysis. So you can now tell whether there is a relationship or not, whether it's a linear relationship or not. Let me look at the comments. Let me check on the comments. I can see from Zadok, nonlinear, Linus nonlinear, Nikon nonlinear, Shekaina nonlinear, Tabitha nonlinear. Yes, there is nonlinear. So in short, I can see you are able to confirm. So those are some of the things that we are talking about. Just driving pattern through diagrams. You see now you can tell there is no relationship, there is nonlinear. Even when you proceed to the analysis now, we go to do the correlation, we go to do the regression, we'll be able to see there is no significant relationship there. There is no significance, degree or inference among the two. You'll be able to see that even if we proceed to do other analysis. Now, if you scroll down, there are some other analysis, I think. There are other analysis. I think that's that's the final. Sorry, that's the final. You are just doing the scatter plot, and you can be able to see. Now, let me go to the data again. Let me go back to the data. I believe that one is okay. However, when you go to regression, now there is another option. When you do the regression, you can just have all those automated, the scatter plot, the histogram, and so many others. You can just you can have them when you'll be doing the regression analysis, but you'll be able to see. So is that we are yet to be there, but don't worry, we will with time. Now the next analysis that I wanted to conduct is a normality test, and we have seen that for this one we can use the QQ plot and the PP curve as well, and also together with the histogram. Again, on the normality, we are looking at the normal distribution of the data. We want to see the bell shape of the histogram. We want to see what kind of a shape, what kind of a distribution shape we have on this data. So again, you can just proceed with the analysis, with the graphs. You go to either Charting Builder or Legacy, which you want. Now from there, we are not using using the scatter plot, but we are using the histogram. Let's use the first one, the simple histogram here. The simple histogram. So on the histogram as well, actually I think we could use the same variable that we are using. We use the BP reduction, and then again we use age. Let's use age. Although now for the age, this one might look, unless we have our engine group, that one could sound better, and it could be even be presented well. Or we can use age. Let's use age. We can try age. I mean, not age, but gender. But do gender influence the BP, BP reduction? Or we can just assume you're using this for the sake of learning. We are not doing this as the actual analysis. We are just doing this for the sake of learning. But we know gender, even not theoretically, not scientifically, can't influence the BP reduction. I'm sure of that, because I've never heard that male have the highest BP compared to female. But let's see, we have the gender, but we need more. We need something that has more columns that we can be able to tell or calculate. Maybe we can use I'm trying to see which other variable we can use, but age, I think let's just understand with age. Let me just click OK, and then we can look at the output and see how it looks like. Let me just share the output. Remember, we are just doing this for the sake of understanding the concept of analysis in this area of assumption testing. So when you have the actual data, same procedure that we are following here, you are going to apply. It's only that our data is just for learning purpose. It's not the actual data, it's not the real data that you can be able to verify or confirm the claim. For now, we are not confirming, we are not verifying any claim. We are just doing this for the purpose of learning. Now, look at this. This is the histogram. This is the histogram, and you can be able to tell. So even if you draw, this is a bell shape here. I don't know how it looks like. It will be lagged to not be straight, as you can see. If you go, it will be just like this. So we will not be able to have bell shape data distribution. So in this case, we can say that the BP reduction or age does not influence the BP reduction. So you can still see there is no normal distribution of the data. There is no normal distribution of data. By look, you should be able to see bell-shaped, that you can conclude that there is a normal distribution. Now, let's look at the QQ plot as well. For this case, let's look at the QQ plot. Now on the same, you just go now to analyze. You don't go to the graphs. We are looking at the QQ and PP. you just go to analyze here, then go to descriptive. And when you click on the descriptive, I know we didn't look at the PP and QQ plot when we are looking at the descriptive and frequency. We just looked at the cross tabulation, exploratory. We looked at the descriptive and frequency. So these other features we'll be able to interact with one by one as we advance from one module to another. So that's the reason why you can see now we are visiting the PP plot and the QQ plot. Now, for now, let me just start with the QQ plot. I think for the QQ plot, we use the quantile. We use the quantile to compare two distribution in terms of the variables. We want to compare two variables. Now, on the other end of the PP, this PP uses the cumulative distribution function of the two distribution, that's the two variables, and these we call them the probability. So just understand one uses the quantile and the other one uses the cumulative distribution function of the two variable again. So that means, in short, both, whether you are using the QQ plot, whether you are using the PP curve, both will show a similar result. But you are going to see that when we will be doing the QQ, and you'll be able to do the PP so that you can be able to compare the two. Now we proceed with the QQ plot. We use the same. We use these variables here. So for the QQ, we are just going to allow me to use the age and the BP reduction. Age and BP reduction. I put them on the variable section. And then from there on the test distribution. On the test distribution, here we are testing the normality. Remember, we are testing the normality. We are not testing the logistic. We are not testing the log normal. These will be covered in an advanced module. Actually, I think almost in the expert level, we have a module on logistic where we will be able to expound more on that. But for now, we are testing the normality, the assumptions. We call them in a research diagnostic test. So the moment you hear diagnostic test, just understand you are testing the assumption or the biasness in a data. Now, from here, when you select the test distribution is normal, you just proceed to OK, just that. And down here, you'll be able to see your results. You'll be able to see your result. We'll come to, for now, we are interested on the QQ plot. We are interested with the QQ plots. Now, can someone tell me if you remember the diagram that I showed you earlier on the QQ curve? I mean the QQ and the PP plot. What did we say? What kind of a QQ is this? Is the data normally distributed or not? How can you confirm? Or can you confirm and tell me? We send only if the data is alongside this and many of the data points are actually touching the line of goodness fits. If these data points are touching on this line, several of them or many of them are touching, then we confirm there is a normal distribution of the data. But you can see for this case, you can see that we have only 1, 2, 3 data points, and then we have 4, 5, 6, 7, 8, 9, 10. And how many data points do we have here? We have so many data points here, more than 10 that are outside this line of goodness fits. So what does that tells you? That this data is not normally distributed. This one tells you the data is not normally distributed. Now, forget about this one. Will be covered in another module. We won't be able to come to this one time, but you can see now when you use now the expectant, when you use the expected normal value, this is like reducing now the errors. Some, the SPSS will be able to reduce some errors, do some analysis by itself and do some errors. And from there, that's the reason why when we have the regression, we always have the error term at the end. We always have the error term. But the SPSS will be able to reduce those errors so that I can be able to, it's like moderating data within, but this one again, as you can see, still there are some, it's moderated, but still there are some data points that are outside this line of goodness of it. Although you can see there are so many points that are close to the line of goodness of it, but in another module we will be able to expound on these as well, on the expected normal value. But for now, we look at, we will concentrate on these expected normal values. We just look at the expected normal values. So those are the main diagram that you're going to focus on. The first one, this diagram we are going to focus on. This diagram that you're going to focus on. Oh, but I can see we have the BP here, by the way. It's like the diagram is for every variable. I think so, because as you can see, this is age, so you can see the curve. That means these the variable data point are not normally distributed. But when you'll be doing regression, you'll be able to get the concept well for this. But it's good again to understand when the data are attached or touching this line of goodness of it, then that means the data is normally distributed. Now from there we have looked at the QQ. Let's look at the PP curve now. We just proceed the analysis. We go to descriptive. We go to, oh, we are looking at the QQ. Now we go to PP. The PP. As you can see, we use the same procedure actually. We use the same procedure. It's only that, as I said, the normal distribution, that's the QQ, will use the QQ will be able to we have the QQ. I've seen the PP will use the cumulative observation for those variables. So for now, we use just the same variable. We have said we use the age and also the BP reduction. So we have age and BP reduction. On the test distribution, we still use the normal, and then we use okay. I said the result will almost be similar. The result will be almost similar. You can see the findings are similar. The normal PP, as you can see, you have the observed cumulative probability. So you can still see majority of the data points are not within the goodness line of it. So we can conclude that the data is not normally distributed. So all these you can be able to confirm, you can be able to verify before you go now to the regression analysis. Remember, we did this on some of these we did when we were looking at the exploratory and descriptive data analysis. Now from there, the next one is let me check on the module, which are the next tests that you are to do. Right. The next one was all right. I think we are done with the linearity. We are done with the linearity. We are done with the normality. Those are the diagrams to test the normality. Now the next is I think there is something we have not. Oh, on normality, we are left on the statistical parts. That's on Shapiro Wilk tests. So I think this one we can do as well, so that we can move on. We can move on with the homoscedasticity. So we go back to our data. I'm trying to get the variables that we can use for this. Right, I think we can just use the same variable that we are using. So we go to analyze, and then we go to descriptive. I think even this one we did. Then from then I go to exploratory. We go to exploratory. So for this one on, I think on the z-plot or the option. Yes, you can see normality plot here. So this is where we are heading there. Now, we are saying we go to, you just click analyze. You just click analyze here. Then from then I proceed to descriptive. After that, you go to exploratory. And then from then you can have your independents. And then the factor lists, those are the independent variable. So for now, we can have the BP reduction. We have the BP reduction on the dependents. And then from then we can have age on the factor. And on the factor list doesn't mean you need to have only one variable. You can add several independent variables that you know are influencing your dependent variable. You can have as many as possible. Now from there you click on statistics. Here you can just and you can see there is an option even to select the outliers. So you can be able to identify the outliers. So for now we just continue with the descriptive. Then on the plot, here, this is where now you need to indicate you want to test the normality plots with the test. This is now we will get the output on the Shapiro test. We will be able to get the result. And then we just click OK. And also you can generate the histogram as well. Those are the histogram that we did. You can also as well test. Same, you can generate and be able to test the normality together there. So after that, you just click continue, and on the options here, you just leave it and check anything, and then you click continue. Now from there, you just click OK, and then we just go to the output. Let me share the output screen so that we can be able to see the output after that. So I believe you remember the stem and leaf that we did. You can see there are so many here on this analysis. There are so many. So sometimes you may get so many analyses that maybe make sense to you. You give one command and you give so many analysis output that maybe are helpful or not. So it will depend on what you are looking for. Now we just go down our interests. We will be able to look at you are looking at I'm not interested with these diagrams. I'm not interested in the diagrams. Remember, I've used age. That's the reason why you can see there are so many diagrams. So it uses age versus the BP reduction. And remember, we have not grouped our age. So it's just one digit, maybe 20, 18, 30. So it needs to generate all those diagrams. But what we're interested on is I can even see the box plots. You remember the box plots? So you can see there are some box plots here. Test for normality. Yes, this is the diagram that I was looking for. Test for normality, this one here. But you can see there are so many stem and leaf box plot. You can see we have the box plot here. So that's the reason why we we were requested to select if you want to know the outlier. By look, you can see the box plot. You can see the box plot here. You can see the box plot. So in short, there are so many analysis outcomes that you'll be able to see. But what I was looking at is these tests for normality. This is what I was looking for, test for normality. Now for this one, you can see here, if we end a blank and maybe we narrow down this, we may have a significant p-values here. But as you can see now, just undotten. But for the chromograph, this is an parametric test. So we are not going to handle it at this level. But there will be a session where we will be able to cover, but not within this module on regression. We will be able to cover Chromograph, Smirnov somewhere else. But our interest was on this one, Shapiro-Wilk. This is where our interest was, because these is now the statistical tests for normality distribution using Shapiro-Wilk. So you can be able, our decision always focus on the significance here, focuses on the significance values here. Now you can see this one is 0.781. All these are greater. All these are greater. So same case, if you remember the decision for this one, we are testing the normal distribution. So it might have a deviation, because we are trying to check whether there is a deviation from the normal distribution. Actually, that's what we are testing. We are testing the deviation from the normal distribution. In that case, remember the hypothesis testing we talked about, the null and the alternative. Our null hypothesis is that there is no deviation from the data from the normal distribution. There is no significant deviation from the normal distribution. That's our null hypothesis. Then our alternative hypothesis is that there is a significant deviation. There is a significant deviation from the normal distribution. The normal distribution. I want to understand the two hypotheses. I've just formulated for the sake of understanding how we are going to make a decision based on the Shapiro-Wilk. I've said always, by the way, your null hypothesis are always negative. That's the reason I've seen there is no deviation. There is no deviation from the normal distribution as a null hypothesis. On the other end, there is the first one you're saying there is no deviation from the normal distribution. Then the alternative is there is a deviation from the normal distribution. So just have that in mind. Now, remember now the decision when you have the p-value and the alpha value. So for this case here, you can see all our p-values are greater than the alpha value. What does that mean? You fail to reject. The null hypothesis if the p-value is greater than the alpha value. Remember we said if, or the opposite, p is less than the alpha value, it means that whatever you are testing is significant. In that case, we reject the null hypothesis. So now, if the p-value of which you can see 0.781, 5.83, 0.583, 0.174, 0.618, 0.637 is greater than 0.05. In that case, we fail to reject the null hypothesis, and for this one, we can conclude that there is no deviation from the normal distribution. There is no deviation from the normal distribution. That's how you interpret it using the significance p-value. That's how you interpret it using the significant p-value. Now, I think this one you understand now about the Shapiro, but as I have said, One time we'll be able to look at the chromograph as well, somewhere else within those other modules, and be able to know, because you remember when I talked about the correlation matrix, we end two. We end Pearson correlation and Spearman correlation, Spearman-Lang correlation. Pearson, we say this is an unparametric, and that's the reason why we use it to test the hypothesis when we are testing the hypothesis and parametric test. And then the Spearman-Lang, which is a non-parametric, also can be used to test the hypothesis on the other end. Although our focus was to test and because you have a module on that, non-parametric, we are unable to cover the Spearman-Lang correlation in details. But as I have said, because this is not the end, we'll be able to continue with these other modules so that we can have a wide knowledge and be able to analyze more data when the data comes on your way, or when you facilitate the data as well, data collection and so on. Now, from there, I think that's what I wanted us to do, recap on. Not a recap. It's kind of a recap, actually. Some of them is kind of a recap. Okay. So I can see a question from Prudence. Let me just check on the chat box. When testing for normality, which of the three do we do first? Histogram, QQ plots, or Wilks tests? We have said we have the two-way, we have the diagram way, where now we have the histogram and QQ plot. Any can start. You are not limited to start with any. It's not a must. You start with the histogram, or you start with the QQ plot, or you start with the Wilks test. You can start with any. So only that for the histogram and the QQ plot, some of them we did when you are doing the exploratory and descriptive analysis as a part of data visualization. We checked on that, and that's the reason I wanted someone to understand that you don't need to go for the regression, or you don't want to proceed to the inferential analysis while you are not sure, or you have not yet confirmed whether you need to go with the inferential or non-parametric or parametric inferential statistics. You are not sure, you don't know. So from the exploratory and descriptive analysis, you can be able to tell through the diagram, like histogram, QQ plot, even before you proceed to Wilks test. And you can use it as well. So Prudence, you are not limited. You can use any can start. You can just maybe learn histogram, QQ plot. You can go with the Wilks test. Whatever you feel you can do it, just go ahead and test your data. From there, now you confirm there is a normal distribution, so I can proceed. I think that's okay. I've explained well, but in case maybe you didn't get the concept well again, you can request I repeat or I pardon on the same. So allow me to share my slide again. So Prudence, you can confirm whether you have gotten the concept or yet, so that I know whether maybe to find some other ones to explain so that the concept can sink well. All right, and now from there we have we're talking of almost scandasticity. So this is where now we are saying that the variances should be constant all along the independent variable. So for this case on homoscandasticity, which is similar to homogeneity of variances, this one we are looking at the constant variance across the independent variable. Now, one of the options is to use the residual versus the predictant. We are going to see that when we will be doing the regression analysis. But you can do the Levene tests maybe before you just proceed the regression analysis, or before you go to regression analysis, you can be able to do the Levene tests. You can do the Levene test first before you proceed with before again you proceed with you proceed the regression analysis. Now we are going to do the Levene tests so that again we can just gain some concept on what Lavin entails and how to make a decision. And you can see a good example there is when modeling cholesterol reduction after treatment, the spread of residue should be consistent across low and high baseline cholesterol levels. So these are the steps on how to do it. I think even we looked at the hypothesis testing. We looked at the different ways on how to test hypothesis. We looked at the ANOVA when we were looking at the testing t-tests. We looked at ANOVA, I think. And we are going to follow the same procedure so that we can be able to get the Lavin test as well and be able to interpret the result. So for the Lavin, we are saying the procedure is to click on analyze, compare means, and then proportion, and then you can proceed to one way where now you need to click reset, recommended, move your dependent variable, you move your independent variable to where it's indicated there, click options, press a check in the homogeneity of variances test checkbox, and then you just click continue. After that, you just click OK. I think this is the same procedure repeated there. Sorry for the repetition, but what I wanted to see here is on the on the decision here. So the p-value from the Lavin test is greater than, choose significance level, choose then you are choosing significance level 0.05, then you can assume homogeneity of variance. If the p-value from Lavin test is greater than, then you can assume the homogeneity of variance. So this statement matters a lot, and this statement is very, very important. So you can note it down. We have said if the p-value from the Lavin test is greater than, you are choosing significance level, which is automatically stated as 0.05, then you can assume the homogeneity of variance. Remember, when this one is greater, of course, if we are testing the hypothesis, it means that we fail to reject the null hypothesis. We fail to reject the null hypothesis. So that statement matters a lot. And I want us to go back to okay, we can also look at multicollinearity. Then we can do both at the same time. We can do the homoscedasticity, and also we can look at the multicollinearity. Now, multicollinearity is saying that this one looks at the relationship between two independent variables. So we are comparing the relationship. Is it strong, positive? Is it strong, weak? Of course, if there is a high multicollinearity between the variables, then it means that we expect to have some biasness on the output results. We'll be able to have some of biasness. Now, for the multicollinearity, I send these are the steps on how to do it. You go to analyze regression and linear option or linear regression. But it's not a must. Actually, you do that so that you can confirm the multicollinearity. There are some other options like Pearson correlation. There are some other options like a cross-tabulation. You can also do that to test the hypothesis. I mean, to test the multicollinearity. Now, when you use the regression, when you use now the statistical procedure, now using the regression now itself, then you'll be able to get some of the tables. You'll be able to generate some of the tables, which will give you some figures like variance inflation factor. And its interpretation is that when the VIF is equal to 1, then this one is okay. But rule of thumb is that the VIF greater than 10, there is a serious multicollinearity. But VIF greater than 5, potential concern, check context. And you can see the same again on tolerance. If this one is 0.01, then the problematic high multicollinearity. So I think we can be able to judge from there. So that means the VIF should be not actually greater than 1. They should only go beyond 1. If it can be within, I think, 0.5 there to 1, I think that one is okay. We can confirm that one is, we say there is no multicollinearity. We can assume that there is no multicollinearity. But if the VIF shows that 510 above 1, that one you need to check. There is a high multicollinearity, and in that case, again, there won't be biasness in the output. So you need to understand that. Now, we have said already, rather than just using the VIF factor to test the multicollinearity, you can even use the Pearson and cross tabulation. And I want to test that. So I want us to use the Pearson correlation because we did it during our last session. And also we can use the cross tabulation again to check if we can confirm the multicollinearity between the independent variable. Remember here we are looking at the independent variables. For the multicollinearity, we are checking the relationship between the degree of relationship between the 2 or 3 independent variable. Now, before we go to the types of regression, allow me to do these 2 tests first. These are 2. We analyze these two assumptions first. We test these 2 assumptions, and then from there now we can proceed with the types of regression so that we can know what kind of regression can we be able to analyze or maybe generate models, kind of models that we can be able to generate for the simple linear and multicollinearity. I mean, the multi-regression, sorry, not multicollinearity, the multi-regression. Now, for the homoscedasticity, we have said we just use analyze, and then we go to proportion. From there, we can go to one way. And then on this other end, for multicollinearity, we can just use the cross tabulation or even the Pearson correlation. So allow me now to go back to the data. And we start with the homogeneity, homoscedasticity. There is some other new assumption like heteroscedasticity, but those one we'll be able to cover during that's on that module on biasness. For now, let's concentrate on these, the main one that really affects all. If we can test 2, 3, actually you don't need to test 10 so that we can confirm the that we can't proceed the inferential like regression analysis. We just do 1, 2, and then from there now we can just confirm. If one tells you this one, don't expect miracles to happen, that the next text will give the opposite of the expected. No. If one gives you the negative, even the other test will give you negative as well. So don't expect, but we do maybe 2 or 3 to confirm, to verify, because it's good to statistically have some evidence so that you can approve that I've done linear assumption testing. I've done normality assumption testing as well. I've done multicollinearity assumption as well testing. So these are the results. From there, even Thomas will be able to believe. Even Thomas can be able to believe. So we start with we start with homogeneity. So you just click analyze. Then from there, you said you go to compare means. From there, you can go to one way ANOVA. Now, on the one way ANOVA, we have the dependent already, which is BP reduction. And then we have the treatment type as the factor. So remember, where you see the factor, just know those are the predictor variables or the independent variables. You are requested to have the independent variables in that box. Now, from there, we have the options. Let's see on the options. So on the options, I'm going to uncheck if there is any other box that's checked on the statistics here, uncheck, and only check homogeneity or variance tests. Just only check this one, homogeneity or variance test. And then from there, you just click continue. We are just only interested with that. We are not interested in anything else. We are just only interested with that. Now from there, we just click OK. And let's go to the output so that we can be able to see again on how how this goes, how it goes. Now, from there, I believe you can be able to see the test of homogeneity or variance. Looking at the Levene statistic, this is what we are looking at, Levene statistics. And what have we said? If the p-value is greater than the alpha value, then what does that mean? What does that mean? You have forgotten. All right, just the decision will be as usual. Always you understand that what you are testing. If you understand what you are testing, then even the interpretation and making the decision will be easier. Yes, fail to inject the null hypothesis. Fail to inject the null hypothesis. All right. Okay, so we are interested on this one, tests of homogeneity. This one, for now, we will not be interested on the ANOVA here because we are yet to look at a statistical test. There are module on that looks at the ANOVA well, where now we look at the F value, but for now we are not interested with the ANOVA at this point here. When we wanted to use the ANOVA, we are looking at the hypothesis testing, where we looked at the significance value here to make a decision. But for now, for this case, we don't have use. It's not usable in this case for now. So allow me just to go back to the data. The next data we wanted to analyze is mode collinearity. And for the mode collinearity, what have we said for the mode collinearity? For the mode collinearity, what have we said? Okay, for the mode collinearity, we have said you can use the Pearson correlation, you can use the cross-tabulation. I know you'll go to the regression and you'll be able to generate all this, but allow me just to use some other ways so that you know how to go about it in case you just come across a data that need to be analyzed. You have said you go to, we can start with the cross-tabulation. Let's start with the cross-tabulation. Now, with the data we have here, let me just go back to the data. I want to explain something. What I was talking about, the computing a variable. I want to compare these two data. Which data was I using now? You can see we have data 4 and data 3. Okay. I want us to compare, or maybe to have a look. Before we go to mode collinearity, there is something I wanted us to understand. What I was explaining about computing a variable. Now, as you can see on this data here, there is nowhere we have used a Likert scale. Sometimes you may use a Likert scale where maybe you want someone to tick maybe agreeing the level of agreement with a certain statement, where maybe you have a Likert scale of strongly agree, not sure, disagree, and maybe strongly disagree, or any other Likert scale, because it's not a must. You have the 5 scale. You can even go to 10, and you can even change some wording. Yes, you can change the wording as well. There are so many ways on how you can have the Likert scale. Now, as you look at this data, for now, if I want to do the regression analysis, there is no way I need to compute because this one is a standalone variable. So there is no way I've used as a Likert scale. But let me just share another data here. Let me just share these other data. Allow me to share these other data so that I can explain the concept of what is this one now? Right, this data. so that I can be able to explain the concepts of computing a new variable. Now, look at these data. These are kind of data. As you can see from ACQ1, this is a statement. These are accounts. I'm just trying to get a variable for this. Access to credit. Let me just use AC as access to credit. Access to credit. So in this case here, you can see we have statement 1, still explaining or collecting data on access to credit. Statement 2, statement 3, statement 4, 5, 6, 7, 8, 9, 8. Now all these 8 statements all are supporting one variable, which is account access to credit. Now, if I want to do some analysis, if I want to do some inferential analysis, that's whether it's a Pearson correlation, whether it's ANOVA, whether it's a hypothesis testing, whether it's a regression analysis, I can do it with the data as it is. So what I'm going to do, I'm going to compute one variable that will stand for access to credit. And there are so many statistical types that you can use. You can either decide to use a mean as a type of statistical. You can use a mode, depending on what you want. Now, to do that, what you need to do is you just come here to transform. This is when I use the transform button. You click here on transform, and then you click compute variable. I've done this so that in case you get data with the Likert scale, I'm not hoping that you'll be able to find another data with some other difficulties, except this with the Likert scale. And this might give you some headache if you don't know how to compute the variable. Now, in this case here, I'm going to have the target variable. So I can call it, because I'm computing using mean, I can call it access to credit, aggregate, ACA or average. ACA, A stands for average. I'm just using any letter just so that it will not look similar with ACQ, because again, remember we can't have two variables with the same type. It can't work. But there are so many function groups here. So we scroll down to statistical actually. And when you click statistical, then you'll be able to see different function types where you will have maximum, mean, and some others. But for you, you're interested to have the mean. You can even use the standard deviation. You can use the sum, variance, all that. But for us, we are going to use mean. So when I click mean, then I need to use this arrow so that these will appear on the numeric expression. So I need to use this arrow. Just click there. And then from there, on this numeric expression, I need to delete the question marks. I need to delete the question mark. So I start with now ACQ1. Remember, I'm calculating the mean for these 8 items, the statement. So I'm going to start with ACQ1. You just click, you enter comma, again you click, you under comma, 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 not a full stop, but a comma, up to ACQ8, because those are the statements that represent the access to credit. Now, once I'm done adding them on the numeric expression, I just click OK. And when you click OK, when you go now to your outputs view, this is what you are going to see. You'll be able to see a statement like this, which tells you that or informed you that you have computed a variable using a mean type. So I believe you can see this one here. Compute ACA, where you have used the mean. We have ACQ1, ACQ2, ACQ3, ACQ4, 5, 6, 7, 8. So those are the statements that you have used to. I know those statements can be variables, but we can't have so many variables within one variable. That's the reason why you need to compress it to have one variable so that we can be able to proceed with the advanced analysis like inferential, among other. So I think that one you have understood. So in case you have a data with the Likert scale, try to do in case you have several statements, try to compute a variable, and then from there you can proceed from there. So let me just now go back to the data. I've done that so that you can be able to, you understand, in case you get a data that needs or maybe have a Likert scale, you need to compute a variable. Once you compute a variable, you can just proceed because you will have a single variable. Like now, I will have a BP deduction. I have a ACA, which is now access to credit is independent. So I can be able now to do the analysis, the advanced, the regression, the Pearson, and all that. Now we are talking about the multicollinearity. We said we can use just some of the exploratory features to do or to confirm if some of the variables are multicollineated. So for this one here, we just click on descriptive and then we proceed to cross tabulation. We just use, let's just get back the outcome and all that. We want to have the BP deduction as any can be on the row. Any can be on the row, so we can have BP deduction on the row, and then we have maybe age on the column, and then from there now we can just click on correlation here. We are trying to look at the correlation. We are not interested in the chi-square now. We are interested in the correlation. So I just click OK, and then just click OK here. So for this one might be, this one is big. But anyway, let me show you something. Let's go and see the results of what we have done. What matters here is to get the output and what we want. I don't know which output. I'm just trying to get the output. All right, this is it. This is it here, and you can be able to see. The Pearson R, and we have the Spearman correlation. For last year, we are interested in the Pearson R. This is what we are interested on. Remember, we said this one can tell us whether these variables are highly correlated, because if there is this one will not be able to show us. Sorry, this one will not be. Yes, we can see the values here. We are not looking at the significance levels, but we are looking at these values here. Sorry, I had mistaken. So for this one, for the significance, we are testing whether the model is significant or not, or whether they are significant or not. But here we are looking at the values here. Remember, this is the value that we are looking at, the Spearman rank. Now, as you can see, we have 0.07 for the multicollinearity. So is this a weak positive or weak negative? This one is a weak positive, because you can see it's a positive 0.07. It's a weak positive. It's a weak positive. And as you can see on this other end, it's not significant. It's not significant because the p-value is greater than 0.05. Now, what can you conclude about that? What can you conclude about that? What can you conclude? If there is no significance, of course, this one there is no, actually even this one there is no high correlation. If this one could be positive, 0. maybe 5 and above, then we could be maybe saying that there is a high correlation. There is high multicorrelation between the variables. But you can see this is a weak positive, 0.07 is a weak positive, almost to 0. There is a weak positive correlation. I mean, there is a low multicollinearity between the two independent variables. Now, again, you can use the Pearson correlation. We have just used the Pearson correlation, by the way. on the cross tabulation. So there is no need to go back and do the Pearson calculation again because it will give you the same result. Now, what else? What else? So I think where we have left now, we will proceed with the types of regression, when we will be covering our next session, which will be on Saturday. I can see it's 7:56, and I think we have learned something, and I can see even the number has gone down. I don't know where the rest are. We were 20, and I can see that it. I don't know whether the concept has if you have understood the concept of regression, or maybe the course has become harder. I don't know. Maybe we will know as we proceed or as we finalize on our last module. I don't know whether you will proceed, or we will proceed with the other modules that we are yet to cover when we will be having the second session for the court one again. So I don't know whether you will be interested, or maybe you will drop from the class, but I believe so far so good. Thank you, Nicole. So for now, I would like to hear from you guys whether there is any concern, any queries so far from what we have covered on the assumptions. Maybe you can give yes, you can give your comments. You can drop your comment over the chat. Let me know whether there is anything that you would like Hai to clarify further, maybe from that from what you have covered, because on Saturday we are aiming to complete this course. We are aiming to complete our planned modules that I was supposed to cover. So for now, allow me to hand over to Nicole, and if there is any question, any concern, you can drop your comment over the chat. If there is any question, just drop your comment over the chat, even over the group, so that we can be able to be on the same page. Otherwise, thank you so much for your patience. Thank you so much for participating, asking questions. I can see we are really together. So Nicole, you can give your closing remarks so that we can end our today session from there.
Thank you so much, Zablon. It has been a very interesting session today. Regression analysis was actually the part where I was really looking forward to from the SPSS training. So I'm glad at least I've gotten something, and I'll make sure to practice to understand it better. I'm also sad that we are coming to an end very soon. We will discuss more and let you know the way forward with the other executive members. And to everyone who has joined today, thank you so much. I hope you guys have gotten
I don't know whether we have lost Nicole, I think. I can see her on the call. I think we have lost Nicole. So can we have someone to pray for us? Because I can see someone. I can see Alan as well. Maybe we can have someone to pray for us so that we can end our today's session. Or I can see Nicole has joined. So Nicole, welcome back. I can see Nicole, she's unmuted, but I can't hear your voice. Maybe the rest can be able to confirm. Are you able to hear Nicole?
No.
Really?
All right. So I don't know how we can reach out to her so that we can be on the same page. Or maybe I can send a text. Let me just write a message. I think she has left again. So for now, I think we can just have volunteer to close with a word of prayer so that we can also proceed with other business. Onesimus, I can see you unmuted. You want to pray for us?
Okay, let's believe and pray.
All right.
Heavenly Father, we thank you for bringing us together today and for guiding our discussion. As we close this meeting, we ask you for your continued wisdom and directions in the tasks ahead. Help us to carry forward the decisions made here with clarity, purpose, and unity. Bless each person with safe and peaceful heart. May our work always bring honor to you and benefit to others. In your holy name we pray. Amen.
Amen, amen, amen. Thank you so much, Onesimus. Keep safe, guys. Do the assignments. Let's meet on Saturday. Bye-bye.